graphing points in three-dimensional space, or at least our attempt to graph them in 2 dimensions to make them look like they're in 3-dimensional space. Keep that in mind. So we're going to begin here by sketching a picture of a coordinate system. So a line has to go this way, that's usually the x-axis. Then you draw a line this way, which is often called the z-axis, and then a line this way, which is then referred to as the y-axis. So let me just do this, zoom in here. Let's make a point in here. As an example, imagine I want to mark this point, 1, 2, and then 3, this way. How do I do it? Well, you got to count. Let me do it in green. Imagine, for example, that this represents 1 along the x-axis. That's the 1 there. Now the y-coordinate is 2. So you need to turn and then make something that is twice as long, once and then twice, because the y-coordinate is 2. Then you need to turn and go up, 1, 2, and then 3. I'm eyeballing it, but it gets the idea across. And then you can move this into position, and that's the point. 1, 2, 3. Those are the coordinates. Let me stress this, that this 1 from the x-coordinate kind of reaches out to here. The 2 from the y-coordinate, that's this part right there. Some people do this as follows. They take little dashed lines and they kind of mirror this over here this way, you see? Just to make it clear that this is referring to the following there, to the 2 along the y-axis. Lastly, the 3 refers to the z-coordinate, which is basically in this position about here, okay? So this is one example. Let's do some additional ones now. Let's do another coordinate system then. Let me draw a line this way, again my x-axis, draw our, say, z-axis this way. And now I'm going to focus on negative y values. That means, for example, the y-axis would go in this position right there. Let me stress this. This is still x, this is still z, this is y now, but the y is negative. What is an example of a point that we can mark here? So we could mark a positive value of x, a negative value of 2, and some kind of positive value, for example, for z like 3. Again, mark off. So you're going to go 1 to the right along x. Now you're going to go 2 to the left along the y-axis, which you can indicate by 1 mark this way and then 2. It should be twice as long as the x, right? Because this is negative 2. And then you're going to turn and you're going to go 1, 2, and then 3 in the vertical dimension parallel to the z-axis. And that then brings you to this point right here. So that's the point 1, negative 2, positive 3. Let's do another example that looks like the following, say. So we're going to have a point. The x-coordinate this time, let's make that, say, negative 3. Make the y only positive 1. And say make the z equal to 4. Why not? So let's draw a coordinate system that will allow us to represent this point. So first I'm going to draw my x-axis. Now how do I draw an x-axis? First of all, notice that the value of x is negative. We indicate that by drawing a line that appears to go into the page. Like this, essentially, see? The y-axis is positive, so you kind of draw it this way. The z-axis is still positive, so you kind of draw it this way right here. And then again, let's label. So now this would be your y, that there would be the x. Let me move this down a little bit so it fits better. And then this here would be your z. We want to mark the points, so you're going to count. Begin always from the origin, just as I have been doing essentially. Notice that x has the value negative 3, so you're going to indicate that by, say, going 1, 2, 3. Let's call this negative 3. In other words, 3 into the page along the x-axis. Because y is 1, you kind of represent that by just going, this way a little bit. And now z has a value of 4, so you got to go all the way up. 1, 2, 3, 4. It's got to be bigger than the negative 3, right? In terms of the length, at least, like this. And then we can put the label attached to it, so it becomes the point negative 3, 1, positive 4. Let's do one that looks like the following next. So point, and it's going to be a negative x, a negative y, and say a positive z, like 3. So let's make up a coordinate system that will allow us to represent this. You could do it as follows. Notice that x is negative, so you could depict that by kind of a line that appears to go into the page. Y is negative, you could do that by a line that goes to the left, essentially. Now the z is still positive, so that would still go this way, vertically. And now let's mark off here. So notice that x is -1. That means basically one mark this way, okay? However you choose to define the length of the mark. But once you've done that, remember, this becomes your measure for what you mean by 1 unit. Then notice that it becomes -2 for the y coordinate there, so you're going to have to turn and go twice as long, but to the left, because y is -2. Then you're going to have to turn, and you're going to have to go 3 units up, vertically this way. And that then becomes your point. And then we can take the label and attach it to the point in this location. Let me be clear in this context that this is the following. This is still the x-axis. Here this is the y-axis, and then here this is the z-axis. I'm also going to erase this part a little bit so it doesn't overlap with the -1 so the label is clear. Next is do a point that looks like the following. We're going to have a positive x, why not? So for example 1, a positive y of 2. And let's make the z negative this time. Imagine it's -3 on the z. Set up a coordinate system. This time I'm going to do it this way. I'm going to have my x-axis. This would be the positive z-axis. You can still draw it in there. A lot of people will. And then this is your positive y-axis. And now this becomes the negative z-axis. And then you want to count off along each axis. Our x is +1, so you're going to go 1 this way. Our y is +2, so you're going to turn 90 degrees basically and go 2 this way. And then our z is -3, so you got to turn and then go straight down 3 units. So like this basically. And then that could be described as our point in this location. 1, 2, -3. Let me emphasize this is x, this is y, and then this here is z. Remember that this is just a 2-dimensional depiction of something that is actually happening in 3-dimensional space. It's likely you are sitting in a room or somewhere like that. Probably you have a corner in your room. So if you look at where the floor meets the wall in a corner, you could imagine that that's basically the origin of a coordinate system, you see? And that would basically then correspond to, of course, this point right here. The origin is this point. And of course, the coordinates of that point are 0, 0, 0. I'm kind of emphasizing the size right there, you see? Other points are located relative to that coordinate origin. But that is this, friends. So if it's been insightful, if it's been helpful, please leave a like, please subscribe. Thank you so much for watching. I will see you in another video.